Good morning and welcome to Space News Day 5. My name's Mike. I read Space News so you don't have to. Let's jump into an Ars Technica article. Which one shall we pick? We have one by Stephen Clark. Sierra Space is blowing up stuff to prove inflatable habitats are safe. We have another one by Stefan called NASA urged Astrobotic not to send its hamstrung spacecraft towards the moon. This is alluding to the Peregrine spacecraft that was launched on the latest Vulcan rocket. That the Vulcan rocket worked just fine, but unfortunately the second stage with the Astrobotic mission, which had I think it was a lunar vehicle, lunar bound vehicle with a series of German and other country satellites, had a leak and I believe ended up returning to Earth's orbit and may end up crashing and burning up in the atmosphere. So we could read that article. There was also one by Eric Berger. NASA loses and then recovers contact with the Mars helicopter. It's difficult choices. All of them probably have some interesting tech-related information. Well, let's start with something new. I haven't heard anything about inflatable habitats in space, so let's have a look at that. We are well on our way to having our habitats ready for launch in 26. In the photo, it is a 300 cubic meter inflatable habitat burst at 77 psi. Okay, so I'm not sure what's on the inside. It looks like a series or a hunk of metal, probably representative of a vehicle. And then on the outside, it looks like bubble wrap. I don't know what their goal is. I don't know what's on top here. I guess this is a series of harnesses that are feeding the electronics on the inside. So maybe not just a hunk of metal. Maybe there's something intelligent going on. Let's see what they say. Sierra Space says it has demonstrated in a ground test that a full-scale inflatable habitat for a future space station can meet NASA's recommended safety standards, clearing a technical gate on the road to building a commercial outpost in LEO. During a December test, their 300 cubic meter inflatable structure withstood 5 times the pressure it would need to handle in space. The so-called ultimate burst pressure test was designed to measure the limits of the soft goods technology Sierra Space is developing alongside ILC Dover, which also built spacesuits for NASA. All right. The 27-foot diameter inflatable structure burst at 77 psi, which is 5x the 15.2 psi, the module's real-life operating pressure. Perhaps best known for developing the Dream Chaser spaceplane, Sierra Space also manufactures satellites and is one of several companies in the mix for helping build a new commercial space station. It's a hell of a job, honestly, building a space station. Lots of cool technology involved. Yeah, I assume this is akin to the International Space Station, so it would host not only astronauts but also many scientific experiments, both internal to the space station and external. Us over here in Canada are very proud of our Canadarm that was developed by a local company, MDA. That I believe assists with manipulating things on the outside of the ISS. We're ecstatic over the results. Senior Director of Engineering and Chief Technologist said, so transitioning from one of our subscale articles, we've done a series of tests to validate our architecture. Being able to go first full-scale life, large integrated flexible environment, burst test, and meet the safety factor by 27% was an amazing accomplishment. Sierra Space is partnering with Blue Origin on a commercial space station called Orbital Reef. Okay, cool, that's new. That's news to me. So Blue Origin is not only in the game of building rockets and in satellite development for their Starlink competitor Kuiper. They are also building a commercial space station concept called Orbital Reef. If the companies see it to fruition, it will become a hub for research, manufacturing, tourism. There you go. If you have a measly $500,000 sitting around, you could tour the Orbital Reef space station and other applications in LEO. The inflatable technology is similar to work performed by Bigelow Aerospace, which pioneered inflatable habitat tech more than 20 years before laying off its entire workforce. Oh boy, let's ask Copilot. What do they say about Bigelow Aerospace? They worked on the technology for more than 10 years and then joined Lockheed for 2 years. In 2022, Buckley, who's Buckley here, took the leadership position. So Buckley, whoever this is, worked on the technology for 10 years and then took the leadership position overseeing the space station work. All right, Copilot has gotten back to us. Bigelow Aerospace is an American aeronautics and outer space technology company. It was founded by Robert Bigelow in 1998, based in Las Vegas. The company built 2 unmanned free-flying. I always do this. I have my my image in the bottom right corner, but I don't see that on the website when I'm presenting. So scream at me, chat, if I'm blocking what I'm trying to read out to you. The company built 2 unmanned free-flying prototypes that flew in 06 and 07, and in 2010 they intended to create a modular set of space habitats for creating or expanding space stations. However, as of 23, the company is defunct. Okay. Here, let's watch the full-scale inflatable space station burst test together.
55 psi, 55 psi, 63 psi, 63 psi.
Trying to emulate the space operations setup as much as possible.
Here comes my number.
75 psi, 75 psi. That's insane.
We're not a company that's trying to escape Earth. We're not a company that...
All right. Cool video. Buckley said he couldn't state definitively whether a life burst test in December was the largest such test of an inflatable habitat design. Okay, so perhaps there are some military ventures that are also exploring this option for space stations. So what we're doing is moving through soft goods certification on our pressure shell. Let's see if there's anything else that's interesting here, anything technical. This is a material which gives you high strength and low elasticity. So I wonder, so I assume they pack this into the rocket, they shoot it up, and then they're able to expand it somehow in space. How does that happen? So there's a material, this material is called Vectran. It's high performance multi-filament yarn spun, stop doing that, from liquid crystal polymer, stronger than steel and 10 times strong, 5 times stronger than steel. Vectran into straps. So technicians mold Vectran into straps which are weaved together to give the pressure shell the strength it needs to hold in space. And speaking of that agreement between this company, what was there? Between Sierra Space and NASA, they have a $172 million funding agreement together. Positioning for the market. Sierra Space laid off 165 employees and additional contractors in November upon the completion of the Dream Chaser. It was these employees were set aside or separate from the Life Habitat program. They're hoping to be able to replace the ISS. That's not a surprise. Oh, here's a new term. NASA calls these commercial LEO destinations, CLDs, and the agency is bracing for government-wide budget cuts in the next few years. That'll be interesting. So if Trump does win, he was the one that founded the Space Force. I'm not sure what it looked like or how it existed as an apparatus prior to his first presidency, but it'll be interesting to see if he wants to fund it both for scientific reasons and perhaps so that something that he came up with or he created continues to grow and blossom. We shall see. There is always the chance, of course, that Biden wins, but it does look to be increasingly unlikely. The ISS is scheduled for retirement in 2030. Okay, anything technological, that's what we want. Here's the concept of the Orbital Reef Space Station. So the expandable modules that they just pressure tested, these soft ones, are, I see 3 of them. So it looks like they are separately attached. So you have your core, the core of your vehicle all along one axis. It looks like a rocket. And then you have 2 or 3 or 4 or 5 or 6 different kind of substations, arms sprouting from the main axis. Apart from Sierra Space, Voyager Space and Airbus have a joint plan to build an outpost called Starlab. I do like Starlab a little better than Orbital Reef, to be called Starlab, and Axiom Space is building modules it will attach to the ISS. Okay, these companies all have funding agreements with NASA. Northrop Grumman was working on its own concept, but last year it abandoned its leadership role and joined Voyager and Airbus as a junior partner on the Starlab project. Earlier this month, NASA, so a bunch of money. There's also a private startup named Vast, also planned to launch its own space station without any NASA contracts, but so far there's not enough to make a privately owned outpost a reality. The ISS costs more than $100 billion to build. Wow, that's a lot of money. And NASA spends more than $3 billion per year operating it, and which includes the pay for cargo and crew transportation. A commercial space station will undoubtedly be less complex and costly than the ISS, but obviously will be multi-billion dollars. The Starlab station would have originally been built using inflatable modules supplied by Lockheed Martin, but since Lockheed pulled out of its leading role on Starlab and Airbus took it on, Airbus is now responsible for building the pressurized modules for the station. Okay, so you have, I'll need to improve my understanding of the terminology here, but you have your core of the space station, and then these arms are called modules. One of the things that's really important is speed. Metal modules are just more proven out. They're much more cost effective. And it says an inflatable as a primary habitat has never flown in space. Okay, and these were comments by Matthew Kuda, Voyager's president. So see if money's a factor. There's also could be a bit of political play where they are behind in terms of the development of inflatable modules, and so they say, oh, they're a bad idea. Let's continue to push what we know works and what we're able to design and develop, which are the metal modules. Maybe a little of this, a little of that. The truth is often somewhere in the middle. The benefits of inflatable modules are clear. They can be launched in a deflated configuration to fit inside of the payload fairing of a rocket. Okay, so this is a new term for me. I've probably heard it before, but it didn't register. Payload fairing is the space within the second stage of the rocket, which carries the payload. And we're going to ask Copilot to help us with that. What are you doing, Copilot? Do I need to ask Google? Don't make me ask Google, Copilot. Oh, you're too slow. It's happening. Copy and search. A payload fairing is a nose cone used to protect a spacecraft payload against the impact of dynamic pressure and aerodynamic heating. Okay, so it's the nose cone. So that. Okay, I'm glad I looked that up. Payload fairing is not that space for payloads inside of the second stage. It's the nose cone. So you could fit an inflatable module in there and then connect it to the space station once you're in orbit. Sierra Space says that the inflatable habitat is 1/3 of the volume of the ISS and can be launched on a single rocket. All right. Thank you, Stefan Clark, for the article. We're going to stop there. Everyone, I hope you have a lovely day. Bye-bye.